So hi everyone, I'm very happy to introduce our recent work. So this is joint work with Schoenebeck. Let's start by considering a scenario where we have two agents, Alice and Bob. They want to predict the election outcome, and the outcome is a random variable W, which can be D or R. Alice has the private information XA, Bob has the private information XB, and they want to exchange their possibly very complicated private information according to some protocol. And they also share some common knowledge like the joint distribution over their private information and the outcome W. So basically, they just alternate making announcements that can depend on the private information and the previous announcements. And one example can be they just alternate announcing their posterior belief about the election outcome. So here is a concrete example. So considering, the conditioning on the icon, their private information just like ID bits, and conditioning on the outcome is like D wins in the end. The probability Alice receive 1 will be 90%, and same for Bob. And the prior probability for the outcome is 50-50. So they have this private information. Alice receives 1, Bob receives 0. And first, Alice will declare her posterior conditioning on her private information, which is 1. And like in such case, she will believe like with a 90% probability D wins. And then Bob actually can infer from Alice's declaration, infers that Alice actually receives 1. And in that case, Bob will update his belief to this posterior conditioning on his private information 0 and the fact that Alice receives 1. And in such case, it go back to 50%, and Bob will announce the belief. And in that case, because Alice knows that Bob already infers her information and a report aggregated information, so Alice will update her belief to 50% too, and announce it. And they just reach an agreement. So, in fact, Allman proves that, like, regardless what protocol they use, as long as like their belief for this probability is a common knowledge between them, in that case, they must have the same belief. And in other case, like they just cannot agree to disagree. And here comes to natural question. And the first question is, okay, how long like they need to reach this agreement to have this common knowledge? And also, does this agreement imply that their private information is already being aggregated? And to the first question, Aronson in 2004 proved that they can actually reach their agreement like quickly. So basically, it's like it depends on how they agree in the end. But even though they can reach their agreement quickly, still we have the question: does this agreement meaningful? And sometimes the answer is no. Let's consider this counterexample. So here we come to this different situation. In the previous situation, Alice and Bob's private information are independent, conditioning on the outcome. Here, they are private. They are just like each of them flip a coin independently, and the outcome depends on the XOR. Sorry, the outcome is the XOR of their results of the coin flips. In such case, their private information are independent, but conditioning on the outcome, it is not independent. It's just like the opposite case of the previous example. And here in this case, like let's assume that Alice receives tails and Bob receives tails. And first, Alice will declare 50%, which is her posterior belief, conditioning on her private information. But in fact, no matter Alice receives heads or tails, she will, like her posterior belief is 50%. In such case, Bob infers nothing from Alice's declaration, and he will report his posterior belief based on his private information still 50. And same thing, like Alice won't infer anything from that either, and they just reach agreement. But this agreement actually, doesn't aggregate the information, because if we really explicitly review their information, they could determine the outcome. So here in this situation, they reach agreement, but it doesn't mean aggregation, and we call this scenario false agreement, and if it's more than two people, just call it false consensus. And then the question changes. Okay, if we already showed that agreement may not imply aggregation, then we are curious, then when does agreement imply aggregation? And this is a question this paper is interested in. So we actually provide a natural information theoretic framework to solve this question, and it also reproves these previous quick consensus results. Okay, so here is the main theorem. So we consider a scenario where Alice and Bob's private information are conditionally independent, conditioning on the outcome. And intuitively, it just means that their private information is similar. They're just like substitutes. And we show that in this substitute setting, no matter what communication protocol they use, actually approximate agreement, we will formally define agreement later, actually implies that they actually get this approximate aggregation. So basically, their agreement approximately aggregates all of their private information. And okay, so before we talk about the formal thing, let's talk about this high-level proof. So the key lemma here is that if their information satisfies this substitute structure, we can prove this subadditivity. It's like the value which we will define it formally later. So the value of the value of their private information is less than the sum of the value of their individual private information. Okay, so this is this subadditivity. And with this subadditivity, we can prove that, okay, so conditioning on the history, everyone agrees approximately. And in that case, it actually implies that conditioning on the history, if Alice agrees approximately, which means that her private information has a small its value is small now, and also the value of Bob's private information is also small. Otherwise they will disagree. And then it is important thing because of this subadditivity, if individual value is small, then the value of even we put their private information together is also small. And if even we put their together is also small, conditioning on the history, it means that the history has already aggregated our information, and that means aggregation. So here is this high-level proof for this main result. And we will see that using the right information theoretic framework, this definition for value and the subadditivity, they can all follow naturally. Okay, so let's talk about the formal proof. So we first introduce some information theory background. even if you're not very familiar with it, we can just like talk about this high level idea. So considering we have like 3 random variables x, y, z, the entropy of a random variable measures uncertainty of the random variable. So if it's not random, it's deterministic, it has 0 entropy. And the conditional entropy regarding like 2 random variables, it means that like conditioning is kind of like given one random variable, what is remaining uncertainty of the other random variable in expectation. And the mutual information measures their like shared information between them. It's kind of like their correlation. And here is similar analogous definition for the conditional mutual, like conditioning on given some like z was the remaining expected shared information between x and y. And here comes the not very commonly used information theoretic concept, which we call this interaction information. So it actually measures like the shared information among 3 random variables. It can be also written as the mutual information between x and y minus the conditional mutual information between x and y conditioning on z. So in fact, we can understand everything intuitively using this Venn diagram. So the set, each individual set can be understood as this entropy, individual entropy. And the like important thing is this intersection of these 3 things. We can understand it as this interaction information among these 3 variables. And we can also like this conditioning thing is like is also like the differ operation in the set theory. So basically we can understand everything using this Venn diagram. And with this background, we can formally define what does that mean for this approximate agreement. So we see like around t, it changed this approximate like more than 2 people approximate a consensus, means that for all individual agents, the mutual information between her private information xi, the outcome w, conditioning on the history, like ht is the history, conditioning on the previous like the history t rounds announcements is less than epsilon. So basically this another thing that like conditioning on the t rounds history, agent i's prime information has small mutual information with outcome. And intuitively, it just means that this is like individual value of this private information is not very significant here. So in that case, we just see that it's like for our agents satisfy this inequality, we just see that they all reach this epsilon mutual information consensus. Okay. And then we can prove this lemma, saying that like if we have this substitute structure, and then we will have this subadditivity. So basically it's a kind of like more general thing. Here is like when x and y are independent conditioning on z, we can prove first they have a non-negative interaction information. And that actually implies that this conditioning on x thing will reduce the mutual information between y and z. And it's like also similar for like, this is just all symmetric. So it's the same for y, like yzx or zxy. And then this actually implies this subadditivity, like the mutual information between the and x and y is less than the mutual information between the and x plus the mutual information between the and y. And so these 3 things can be actually proved by this Venn diagram. So the reason why independence, like the first, like the non-negative interaction information, because we can write down the interaction information among x and y and z as the mutual information between x and y minus the conditional mutual information between x and y conditioning on z, which is 0 when x and y are independent conditioning on z. So in that case, we have it's just equals the mutual information between x and y, and mutual interaction information can be positive, can be negative, but mutual information is always positive. It's one important property, and because of that, this is positive. And for other conditioning reduced mutual information, subadditivity mutual information, we can just prove that according to the chain rule, or use this Venn diagram. Just think this mutual information as intersection, and this conditional thing as the differentiating operation. Okay, so this is if we have this information theoretic background, and then we can easily prove that when this is substitutes, we have this subadditivity of the mutual information, and that actually provides us a formal proof for our main result. So after T rounds, we have the capital HT represents all the public announcements during the T rounds. And after T rounds, we aggregate the amount of information we aggregated is the mutual information between the T rounds announcement HT and outcome W. But in fact, if we can explicitly reveal our agent's private information, the total amount of information we can aggregate is the mutual information between all private information, x1, x2 until xn, and outcome W. And in such case, the amount of information that hasn't been aggregated is their difference. And by using some chain, still we're just using the chain rule again. This exactly is the conditional mutual information between all people's private information and W conditioning on the history, and in that case we can just use the subadditivity if conditioning on W, all people's private information independent, this substitute thing, we can prove this. We just generalize our previous lemma to n people and prove this subadditivity for n agents. And in such case, the conditional mutual information between all private information W conditioning on history is less than the sum of this individual private information, the mutual information between private information xi and W conditioning on the history. And as we defined before, here they already reached this epsilon mutual information consensus. So the individual mutual information will be less than epsilon, and in total it will less than n epsilon. So here, this is this formal information theoretic proof. And in fact, like we mentioned before, within this information theoretic framework, we can also prove this quick consensus result quickly. Basically, we have a very natural potential function, which is aggregating information, like we mentioned before, the mutual information between these G rounds and public announcements and W. And also, we need to kind of analyze the growth rate of this potential function. And this is this amount of information of the declaration. We just use this small HIT to represent at round T agent I's public announcements. So basically, the growth rate basically equals the conditioning on mutual information between agent I's public declaration, for agent I, her public declaration and outcome, conditioning on what happens before she makes her announcements. And here comes to this quick consensus thing. So basically, when some of them has like large disagreements, they just like disagree with with other people. In that case, her private information actually has a very high value. And in that case, if the protocol is defined properly and we just use the protocol, like people they just exchange their posterior belief, or they just doing this discrete version of their posterior belief follow from Aronson 2004. Within that protocols, we can show that if their private information has a high value, then their public declaration will also have a high value. And this actually implies that the growth rate of this potential function is large, and this potential function is always, the mutual information of the mutual information between the history and outcome is always less than the entropy of this outcome is bounded. In this log2 base thing is bounded by 1. And in that case, the potential function is bounded and it has a high growth rate. And it's just like, we will reach our consensus pretty soon. And it also has a connection to this prediction market. So basically, if we are consider prediction market with log scoring rule, and people they just change their belief from this current posterior belief to their current posterior belief according to conditioning on the history, and to the posterior belief conditioning history and her private information. In that case, they will be paid this conditional mutual information thing, and then this epsilon mutual information consensus means that they cannot make a lot of money in expectation using their private information. And the quick consensus means that the market will quickly reach a convergence. And this no forced consensus substitutes just means that when people's information structure satisfies substitutes, then the convergence implies aggregation. Okay, so here is a summary. We propose this information theoretic framework. It can help us easily prove that no false consensus with substitutes, and we also reprove this quick consensus. In fact, we will prove another strategic revelation result, and you can read the papers for more details. And future, hopefully, this framework can be employed in other scenarios like learning, like social network. Thanks.